Hello, everyone. Welcome to our third session of our Python data and scripting workshop. Thanks for coming back and being with us again tonight or this afternoon. So last time we looked at using NumPy to load data in from a file that was tabular. So this is a file that had rows and columns. We talked about how to access data in a NumPy array and how to do some sort of analysis using that NumPy array. And then we looked at plotting with matplotlib. At the end of the session, we gave you a homework assignment, and that homework assignment was to, I need to basically parse an XYZ file and measure the distance between atoms. So we are going to start out today with going over that homework assignment. Then we'll be talking about how to write reusable pieces of code called functions. And then we'll be looking at using a little bit of the command line. So that's what we have for tonight. And Dr. McDonald is going to take that over. So I'll just hand it over to Dr. McDonald.
All right. Hi, everybody. So I'm going to share my screen. So you can see that I'm on my NanoHub dashboard. So if you've gone to NanoHub and you've logged in, then if you come to this upper right-hand corner where it says logged in and you mouse over that, you can click on dashboard and it will take you to your dashboard. There are two ways to get back to the Jupyter Notebook that we were using last time. Over here on the right side under My Tools, since you all use the Jupyter Notebook recently, you probably just have it right here, and you can click on this. So this should take you to the Launch Tool page. If you don't have that, if you're on your dashboard and you don't see the Jupyter Notebook under the tools, then I would just come down here to our group and go back into our MolSSI group. And then if you scroll down and you click on the information for this workshop, then right here above the sessions, you can see this link that says Jupyter Notebook on NanoHub, and you can click on that. And that too will take you to this Launch Tool button. So you can get to it either way. You can either get to it for the group, or if you just come up here to where it says logged in and you go to your dashboard, it should be under your My Tools, your recent tools. So I'm going to click on it. Then it should say Jupyter Notebook with Anaconda. And I'm going to come up here and I'm going to click this blue Launch Tool button. All right. Then once I get to this point, I should see my folders here. You may not have all the same folders that I do, but you certainly should have the MolSSI workshop folder. So I'm going to click on that. And then many times from this juncture, we've come up here to New and started a new Python 3 notebook. And you definitely can do that. But I had this notebook already going, this geometry analysis starter notebook. And I know that I posted this in the group so you all could download it and then start your homework in this notebook. So if you have this notebook somewhere in your files, you can go ahead and click on it to open it. And if you don't have this notebook in your files, just come up here to New and start a new Python 3 notebook. And then I'm going to just be here in my notebook where I have the directions for the project. Okay. While I am waiting, you do not have to do this. You can just stay on your notebook page, but I'm going to click back over here to my file navigation window. I'm going to go into the data folder and I'm going to open this water.xyz file so that we can remind ourselves what it looks like. Okay. All right. So again, here's my notebook with my instructions. I'm going to analyze this XYZ file for water and measure the distances between all the atoms. And then I've said that this is what I want the code output to look like. I reminded everyone of the distance formula from geometry. I reminded everyone how to take the square root in NumPy and how to square stuff in NumPy. So that was all information that was provided. So now I'm going to start my code to analyze this XYZ file. I'm anticipating, based on these instructions, that I'm certainly going to need to use NumPy because I'm going to take the square root. So I'm going to start by importing NumPy. And then I'm also probably at some point going to have to put together a file path in order to open my XYZ file, which means I'm going to need that OS module. So I'm going to begin by just importing those two modules. And then, of course, when I hit Shift-Enter, it seems like nothing has happened, but I have now imported these two modules and have them available for me. If I want to parse this XYZ file, the first thing I need to do is tell the computer the file location. So I'm going to create a variable called file location, and I'm going to have my one of my favorite functions, OS path join, put my file path together for me. So in order to get to that water.xyz file, if you remember me clicking through just a minute ago, I clicked on the data folder, and then I clicked on the water.xyz file. Okay, and if you want to check your work, like Dr. Nash taught us last time, there's no reason to write all of your code and then check it. You should check it as you go along. So I'm just going to print that file location to make sure that it looks good. All right, now that I have my file location specified, I have my file path ready, I almost just pointed to my computer screen like y'all could see that. I don't know what I was thinking. I just had a moment there. But now that I have my file path set up, I need to open the file. Last class, we learned two different ways that you could open the file. We learned about read lines, which lets you open any kind of file, and it reads in every line from the file as an element of the list. And we also learned about NumPy genfromtxt, which was a way to open files that were tabular, that had data in rows and columns. And I'm going to click back over. You guys can stay in your notebook, but I'm going to click back over and look at the XYZ file again and try to think about what I should do here. And the real truth is, for this particular file, I could use either one. I could use read lines, or I could use NumPy genfromtxt. And truthfully, both of them have pros and cons. If I look at this looks like data in rows and columns to me. So my inclination is to try to do this with NumPy genfromtxt. So I'm going to create a new variable called XYZ file, which is going to be the information from my XYZ file. And like I said, I'm going to use NumPy genfromtxt that I learned about last time. And I know that I have to specify the file name, and that is just going to be my file path that I have saved as file location from my previous line. And then, and maybe I should have done this, I'm going to come back to this for a quick second. I'm just going to delete this and come back to it in a minute. Okay, maybe I should remind myself of how to use NumPy genfromtxt. So I'm going to do help on NumPy genfromtxt. Okay, so I'm going to scroll down and see what I can learn here. So I must specify the file name. And I know that because every other thing has a default value. If you have an equal sign, that means that this is the default value. But file name has no default value, so I've got to specify my file name. Another thing that I'm looking at here is that my default data type is floats. And floats are numbers. And if I look at my file here, I have some numbers, but I also have some words and I also have some symbols that are letters. So I'm thinking that one of the things that I'll need to specify is my data type. One thing you may remember us doing last time is specifying a comma for our delimiter. But if I look at this data, it is not comma separated. So I think I'm going to scroll down now to my next box. I think if I was doing this, this would be my first attempt. I would say XYZ file equals numpy.genfromtxt. And then I know I have to specify my file name, which is that file location variable I set up just a minute ago. And I just figured out that I need to set my data type. And I know that Dr. Nash taught us last class that Unicode is a good data type if you have a mixture of words and numbers, if you have letters and numbers. So this is going to be my first attempt at getting the information from my file using numpy genfromtxt. All right, here I go, Shift Enter. Now I can see I've gotten an error. So I'm going to scroll down and I'm going to read the bottom of the error message. And it said in line number 2, I got 3 columns instead of 1. In line number 3, I got 4 columns instead of 1. And I get that message several times. So I'm going to click back over and look at my file. And it seems like what has happened here is that when numpy genfromtxt read in the first line, it was like, okay, I got this. There's only going to be 1 column for each row. But then for the second row, it got 3 columns because there are 3 words there. And then for the subsequent rows, it got 4 columns because there are 4 there. Okay? Now, we haven't ever encountered this particular situation before, but as it turns out, the way numpy genfromtxt works is that every row has to have the same number of columns. So we've either got to give up and go back and use read lines, or we've got to use, I'm going to click back over now, we've got to use this skip header option. And I think Dr. Nash pointed this out to you last class period, but we didn't ever use it. But here, if we want this to work, we're going to have to do skip header, and we're going to have to skip the first 2 lines, because those are the lines that are different. Those are the lines that are not coordinate lines. Okay? So then I'm going to hit Shift Enter. And since I didn't tell it to print anything, it's not going to print anything, but I've now read in all the information from my file into this variable called XYZ file. And I could print XYZ file if I wanted to, and it would look like this. Now, there's 2 things that I want to point out about this. Number 1 is I can tell that right now it thinks everything is a string. And I can tell that because it has everything in these quotation marks. So I know right now it thinks everything is a string. Further, I'm thinking ahead. And I know that the symbols over here are going to need to be a different data type than the numbers. So the next thing I'm going to do is I'm going to do 2 slices to separate off the symbols from the coordinates. So I'm going to make a variable called symbols, and it's going to be a slice of XYZ file that is just the symbols, which are over here in column 0. So I'm going to say XYZ file, every row, column index 0. And if I print this, I can see that I've now successfully pulled off just those symbols. All right, the next thing I'm going to do is I'm going to create another variable called coordinates. And I'm going to take a different slice of XYZ file that is just the coordinates. So that's this section right here. So again, I want every row, column index 1 to the end. So the fact that I didn't include a second index here means I'm going to start at column 1 and go all the way to the end. Okay? I'm also going to remember while I'm here that I need to recast these as floats because here they were strings up here. So I'm going to say coordinates equals coordinates as type float. And then let me print the coordinates just so I can check my work. And coordinates is very hard to spell. And I think I've done it because I've clearly taken my slice and I've just gotten the number part. I've just gotten the coordinates. The quotes are gone, so it looks like I've successfully recast them as floats, and I have printed those coordinates. So I'm just going to pause here for a moment. I'm going to try to scroll so you can see more of my screen. This was where I read in all of the information from my file using genfromtxt. What I discovered is that every row had to have the same number of columns, which meant the only way I could get this to work is if I used that skip header option from NumPy genfromtxt. How did I know that was an option? Because I had used the help menu and I see this skip header option right here. Okay. Then when I printed this, I kind of thought ahead and I thought that the numbers were going to have to be a different data type than the symbols because the symbols would have to be strings and the numbers would have to be floats. So I took 2 slices, one of just this column index 0 and one of column index 1 to the end. And then I recast the coordinates as floats. And if you missed the very beginning, I'll scroll up real quick. I started off by just importing NumPy and OS. And then I used OS path join to put together my file location, which was data water.xyz. And then the only thing I've done since then is I've read in all the information with NumPy genfromtxt, and I've done these 2 slices to separate the symbols from the coordinates. All right. So the next thing I need to do is I really need to start thinking about the heart of my program. And I'm going to scroll up to my directions. And I'm going to need to use this distance formula and find the distance between every set of atoms. So essentially, every atom has to take a turn being atom number 1, and every atom has to take a turn being atom number 2. Okay? So if I'm thinking about that, if every atom has to take a turn being atom number 1, and every atom has to take a turn being atom number 2, I'm thinking that I need a for loop. And specifically, I need to use that range for loop, the kind of for loop where we do something a particular number of times. So I'm going to say for number 1, and that's just going to be my atom number 1 counter, in range 0, 2, and what do I want this to go to? I want it to go from 0 to the number of atoms that I have in the molecule. So I'm going to make a little variable called number of atoms, but I haven't ever calculated number of atoms. So I need to come up here before my for loop, and I need to calculate the number of atoms. And the number of atoms is just the same as the number of symbols that I have. So I'm just going to measure the length of symbols to get the number of atoms. Okay, now back to my for loop. So this outer for loop is going to count over atom number 1. And then I need another for loop to count over atom number 2. And remember, I want every atom to be atom number 2. So this for loop is also going to go from 0 to number of atoms. All right. So again, num1 is my counter for atom number 1, and it'll be 0, 1, 2. And num2 is my counter for atom number 2. So now I basically just need to program in the distance formula. So I'm going to say, okay, my x distance is the difference between my two x coordinates. So I need to access the x coordinate of atom number 1. So that's going to be coordinates for atom number 1, and then and that basically is this row, and then which coordinate is the x coordinate? It's the one in column index 0. So this notation right here, okay, this is telling me I'm going to be on atom number 1's row, and every atom is going to take a turn being atom number 1. So I'm going to do every row, and then the x coordinate is in column index 0. Then I need to subtract the x coordinate for atom number 2. So it'll be atom number 2's row, the x coordinate, which is still going to be column index 0. Y distance will be very similar. It'll be coordinates, atom number 1, and now the y coordinate is in column index 1. And then the y coordinate of atom 2 will be atom number 2's row, the y coordinate. And then z will be very similar. It'll be coordinates for atom number 1's row, the z coordinate, which is column index 2, minus the z coordinate for atom number 2, which will be atom number 2's row, the z. All right? Then once I've done my subtracting, I need to actually find the distance by saying the square root, so I'm going to have to use that numpy square root function, of x distance squared, here, x distance squared plus y distance squared plus z distance squared. And that's just the implementation of the distance formula. All right. Now I'm going to scroll back up and I'm going to see what I wanted to print. And it looks like I wanted to print the symbol to the symbol and then a colon and then the distance. Okay. So I'm going to do a print statement. It's going to be an F string print. So I'm going to put my big F. So I wanted to print the symbol for atom number 1. So that's going to be symbols atom number 1's row, 2 symbols for atom number 2. Then I wanted a colon, and then I wanted the distance. And I think if I hit Shift Enter, that this is pretty close to what I wanted. This looks pretty close to my prescribed situation up here, but it seems like I've only printed 3 decimal points here. So I think Dr. Nash showed you how to do this last time. If you want to modify the printing, come up here inside the curly braces and do colon dot 3F, and that will only print 3 decimal places. So if I hit Shift Enter again, Now it is looking pretty good. While I'm waiting for everybody, I'm going to sort of talk through this double for loop again. The reason I used a double for loop is because in the distance formula, I know I have to measure the distance between atom number 1 and atom number 2. The x-coordinate of atom number 1, the x-coordinate of atom number 2. I want every atom to be atom number 1, and I want every atom to be atom number 2. So I had to use 2 for loops here, one to count over atom number 1, one to count over atom number 2. Okay? Then these lines, these 4 lines, just implement the distance formula. This is atom number 1's x-coordinate minus atom number 2's x-coordinate, atom number 1's y-coordinate minus atom number 2's y-coordinate, atom number 1's z-coordinate minus atom number 2's z-coordinate. So this is the x, the y, and the z. And then the distance formula, I just squared each one of those and then took the square root. And then I did my print statement in the manner that the instructions told me to, including formatting the distance to only print 3 decimal places. So this was pretty much it. This was what I did for my project. Dr. Nash, did you have anything else you wanted to add here?
Yeah, I'll add a little bit. So this this structure that you see with a for loop inside of a for loop, I think it's something that at first seems very confusing, but it's something that if you program, you're going to see over and over and over again. So it's it's kind of a common pattern that's used, and it gets sort of easier to identify and understand what's going on in it, sort of just by practicing working with it.
All right. I do want to emphasize, I know some of you are not typing in the homework solution because you already finished it for the homework. But I do want to emphasize that if you didn't finish the homework solution, it is very important that you get caught up at this point, because we're going to be using this homework solution code for the whole rest of our class today. So we're going to be building on and changing this code for our whole class today. Okay. All right. So there's a couple things. So this is the homework. This is what you were assigned to do for the homework. If you got it to here, then I would say you accomplished the homework as assigned. There's a couple ways that I want to talk about that we could improve this code. Okay. So one of them is that as chemists, and I don't really, I know that Dr. Nash on the survey asks for all of your majors. So she knows all of your majors, but I don't. But as chemists, we know, for example, that hydrogen 1 and hydrogen 2 are not actually bonded together. Okay. This distance is actually too far for these to be bonded together. So hydrogen 1 and hydrogen 2 are not actually bonded together here. So what I want to do is I want to make up an admittedly arbitrary rule about what does and doesn't count as a bond. And I want to only print the ones that are actually bonded together. So I'm going to write a note to myself using the hashtag, the comment, and I'm going to say, I am going to modify my code to only print the atoms that are bonded. And then I'm going to say that my arbitrary rule is going to be that the distance must be less than 1.5 to be considered a bond. And I clearly completely made this up. I totally made up this rule that it has to be less than 1.5 to be considered a bond. But we're going to go with it. So I'm just going to take my box here with my double for loops, and I'm going to copy it, and I'm going to paste it into this cell below. And now I'm going to add something, and I'm only going to print it if it is less than 1.5. Okay? So the way I'm going to do that is I'm going to add an if statement right above my print statement. And I'm going to say if distance is less than 1.5, don't forget your colon. If that's true, then I want to do this print statement. So I'm going to indent this print statement so that it only does the print statement if it's less than 1.5. Okay. And remember, if I had something else I wanted to do, I could do an else alternative, but I don't really have anything else I want to do. I just only want to print it when this if statement is true. So now if I hit Shift Enter to run this again, now you can see that it's not printing. If I scroll back up here, it's not printing this H1 to H2 distance anymore. It's only printing the ones that are less than 1.5. Now, at this point, you may be like, wait, McDonald, I've got a better idea, because look at all these zeros. This isn't useful information. We know that the distance between an atom and itself is 0. So why don't we change our if statement and we only print if the distance is greater than 0 and the distance is less than 1.5. So both of these conditions have to be met in order for it to be printed. And now if I hit Shift Enter again, now it'll only print oxygen to hydrogen 1, oxygen to hydrogen 2, hydrogen 1 to oxygen, hydrogen 2 to oxygen. So it's eliminated all the ones that were not actually bonded. All right. Now, does anybody see any other way that we could improve our code? Does anybody have any other ideas looking at our output here? Is there any of this that seems redundant or unnecessary? Here's an idea that I have. Oxygen to hydrogen 1, that distance is literally the same measurement as this distance. It's literally the same measurement as hydrogen 1 to oxygen. So do I really need to do this twice? And I can see why it's doing it twice, because when this is atom number 1 and this is atom number 2, I do it. And then I do it again when this is atom number 1 and this is atom number 2. Okay? So if I do the distance between atom 1 and 2, I then don't need to do the one between 2 and 1. I'm going to say that again because that's confusing. If I've already measured the distance between atom 1 and 2, then I don't need to measure the distance between atom 2 and 1 because I've already done it. So how can I put that into my code? I'm going to write down what I just said. If I have measured atom 1 and 2, I don't need to do 2 and 1. Now let me think about how I can put this into my code. If I've already done 1 and 2, I don't need to do 2 and 1. Similarly, let me do this again and see if I can really figure it out. If I have measured atom 2 and 3, I don't need to do 3 and 2. So let's look at the pattern in the numbers here. The ones I want to do, the first number is less than the second number. And the ones I don't want to do, the first number is bigger than the second number. So one way that I could fix this, and I'm going to copy my whole little box again and paste it under here. Okay. So one way that I could do this is before I even start measuring the distance, I could say, only do all of this if number 1 is less than number 2. Okay. And don't forget your colon. And then all the stuff that we want to be inside that if statement, we have to indent over. So I'm going to highlight it all and hit the tab key. And then all of this stuff that I just indented, we're only going to do this if number 1's index is less than number 2's index. And in programming, this is called doing the upper triangle. If you do 1 and 2, you don't do 2 and 1. All right. So now I'm going to hit Shift Enter. And now it's only going to do the unique ones. It's not going to do any duplicating. All right. And doing both the double for loop is hard to understand. And then only doing the upper triangle can be very hard to understand. And while we're waiting on the questions to come in, Dr. Nash, do you have anything you want to add on this? Because this is going to be a very tricky concept.
Sometimes, say when I was learning to program and I had a problem like this, I found it actually useful to write out on a piece of paper what I wanted to do. So sometimes it would even be like, I would write the numbers 1 and 2 that I wanted, sort of the way Dr. McDonald has it in comments here. But if you're solving a problem, you might find something like that useful.
One thing I want to mention while we're waiting here for a moment, one thing I want to mention is that I am just printing the output to the screen because that's what I told you to do in the homework assignment. But based on what you learned last class, you could, for example, write this data to a file if that were something you were interested in. That's something that we learned last class that you could certainly do.
Dr. McDonald, we're having a little bit of trouble with indentation, and I'm having trouble explaining it over text. Can you show sort of an indentation error and what that error message might look like and how we can solve it?
Where would be a good place to make that error, like right here?
Yes.
Okay. So if I don't have that indentation correct, oh gosh, now it's crazy. Okay, let's say I didn't remember to indent this after my if statement. Then when I ran this without the indentation, it would say, oh no, there's an indentation error. I expected an indented block. And it would point to the error being at X distance. And if I look at X distance, I'm like, wait, nothing looks wrong with X distance. That's exactly what I had before. How could that be messed up? And the key thing to remember is that anytime you have a colon, the next part should be indented. Something should be indented. The thing that should be indented is everything that you only want to do if this if statement is true. Okay, so all of this I only want to do if number 1 is less than number 2. And the way that I communicate that to Python is I indent it. And if you just highlight it all like I've done here and you push a tab, it'll indent it all over. And then it will work as expected. Was that a helpful demonstration, Dr. Nash? Is that what you wanted me to do?
Yes, thank you. I also want to point out that, Dr. McDonald, can you put your cursor at the beginning of the line that says X distance and then press space one time? So if you have something like this will also cause an indentation error because it has to line up exactly.
Yeah, so now it says unindent does not match any outer indentation level. So it means something is not lined up here. And another general tip that Dr. Nash taught me for reading Python error messages is it's telling us that the error is on the Y distance line, but sometimes it's actually on the line above it. It's the X distance line that's actually not properly indented. So if you can't find your error, always think about checking the line above. All right. Okay, so as I mentioned, we're going to continue for the rest of our lessons today. We're going to continue working with this code, okay? And the first thing that we're going to do is we're going to rework our code a little bit where we have some reusable code blocks. And these reusable code blocks are called functions. And a function in a code is usually, it can be short, but there are functions that are more complicated. But the key thing about a function is it usually has one computational purpose. It's a little bit of code that has some inputs and some outputs that has one computational purpose. When would you write a function? If you're ever writing code and you find yourself copying and pasting code, you should always write a function because a function makes a code block reusable so you can use it instead of copying and pasting. My students are often not convinced by this argument. They're like, McDonald, cutting and pasting is fine. What's your talk here of these functions? And another reason that another thing I've really come to believe from Dr. Nash is another great reason to write functions is that functions make your code a lot easier to test. Because functions kind of break your code down into little individual blocks that only do one thing. So if you can test those little blocks, then you know where your code is working and where it's not working. Okay? So again, a function is a reusable code block that you're going to write in your code because you're going to use it more than once. Okay? So let me show you how you write a function. And I'll tell you, if you're still a little iffy on functions, that's okay. Let me give you an example and let me show you how to use one in our code, and maybe it'll become more clear. Okay? So fundamentally, this is how you write a function. To write a function, you start by saying DEF, that stands for define function, and then you give your function a name. Then in parentheses, you list all the parameters that your function is going to accept. These are sort of like the inputs for your function. Then you put a colon, and then down here, this is sort of your code that does stuff with your parameters, because remember the parameters are the inputs. And then you're going to type the word return. And then this is going to be a value to return that is presumably something that you calculated in this middle section. Okay? And this is not functional code. This is just the definition of a function. So I'm going to actually comment all of these lines out so that I can remember them, but they won't mess up my code. Okay? Now, looking at our geometry analysis project, one of our key math operations was measuring the distance between 2 points. Okay, that was one of our key math operations. And that seems like something that we might want to reuse. There might be other places where we want to measure the distance between 2 points. So I'm going to create a new function. Okay, so I'm going to create a new function by saying def, and the name of my function is going to be calculate distance. Okay. Now, whenever I'm thinking about the inputs and the outputs of a function, it's best to try to clear your mind of how you're going to use the function in your code. Like, don't think about that. Just think about what is the simplest set of inputs that I could use that would enable me to accomplish this. And if I'm measuring the distance between 2 points, if that's the purpose of my function, the simplest inputs that I could possibly think of is just 2 sets of coordinates. The coordinates for point number 1, the coordinates for point number 2. So I'm going to make that be my inputs. I'm going to accept the coordinates for point number 1, the coordinates for point number 2. Okay? Don't forget your colon. Don't forget to indent. And now I need to use these parameters and actually do whatever it is I want this function to do. So I want it to calculate the distance. So I'm going to say my x distance is the difference between the x coordinate of number 1. So that's going to be coordinates number 1, and the x coordinate is usually listed first. So that's going to be index 0, minus coordinates number 2, x coordinate. Okay. The y distance is going to be coordinates number 1, the y coordinate, minus coordinates number 2, the y coordinate. And my z distance is going to be coordinates number 1, the z coordinate, minus coordinates number 2, the z coordinate. And then once I've got those measured, I can measure my distance and say I need to do the square root, so numpy.sqrt of x distance squared plus y distance squared plus z distance squared. And then once I've calculated that distance, that's what I want to return. So I want to return the distance. Okay. So again, when you are writing a function, couple things to remember. When you're determining what your parameters are going to be, what your inputs are going to be, okay, when you're determining that, try to think about the simplest way it could possibly be. If I want to measure the distance between 2 points, the simplest thing I could do is just have 2 sets of coordinates. Then I write the body of my code using these parameters because these are going to be the things that are input. So that's my code here. And then once I calculate the thing I'm trying to calculate, then I know I'm ready for my return statement. All right. Now, when I hit Shift Enter here, it's going to look like nothing has happened, but now I can test my function. Okay. So I'm going to call my calculate distance function, and I'm going to feed in 2 sets of coordinates. So I'm going to go coordinate 0, 0, 0. And I'm going to go in coordinate 0, 0, 1. And the reason I chose two such simple sets of coordinates is because it's easy for me to calculate the distance between those in my head. So when I hit Shift Enter, I know that the answer should be 1. And if I don't get 1, then I have messed up. But I have messed up more because I forgot to put the commas in my lists here. Fail. Okay, I try again. All right. Now I've done it right, and I can see that the distance is 1. I'm going to pause here for a second, and I want everybody to spend a minute doing tests. Like, make up some different coordinates and do some tests and see if you think your calculate distance function is working. I chose those 2 points because I know that that makes a 45, 45, 90 triangle, and that distance should be the square root of 2. And I think that's pretty close to the square root of 2. But again, I'm going to pause here for like a minute and make sure you get this calculate distance function defined. Don't forget to run this cell. And then I want you to do a couple tests for some different points and make sure yours is working. I'm going to show you something else that you can do when you're doing your tests. I've just been typing in my coordinates directly into the parentheses, but if I wanted to make some other variables, like if I wanted to say, okay, Adams 1's coordinates are 0, 0, 0, and Atom 2's coordinates are 0, 0, or 0, 0, 2. And then I could say calculate distance atom 1, comma, atom 2. That would be another thing that I could do. I could specify it like that. But it doesn't matter. That's another thing you could do. All right. Dr. Nash, did you have anything you wanted to add on this function business?
You may have said this, but I don't. Maybe I missed it. But we've been using functions a lot already. So when we were doing numpy.mean or plt.plot, those were functions that other people had written that were in libraries. So if you keep working with Python, if you sort of become a Python developer, one thing that you might do is write your own library. And then you'd just be you'd be writing a lot of functions and then making it so that other people could use your functions.
Yeah, so there you go. Okay, so the next thing I want to do is I'm going to scroll back up. I'm going to scroll way up. And I'm going to find my box where I had my geometry analysis code. And I'm going to copy this box. And I'm going to paste it down here. And now I'm going to modify my code to use my new function. Okay? So instead of doing all of this, I'm just going to say, if number 1 is less than number 2, I want to measure the distance by calling my calculate distance function. I don't know why I wrote distance calculate. Okay, I want to modify my code by calling my calculate distance function. And then what do I need to feed in here? I need to feed in the coordinates of atom number 1 and atom number 2. Okay, so let's think about how my code is working. The coordinates are stored in an array called coordinates. So I need to pass in the coordinates of atom number 1 and the coordinates of atom number 2. Remember, this calculate distance function is going to return the distance. So I'm going to set that equal to a variable called distance, and then I'll have it all ready to do my checks. So that is what I'm going to do there. And if I hit Shift Enter, it should give me the exact same output it gave me before, because I didn't change the functionality of my code. I just used my function. So the output of the code should really be the same. All right, so the last thing we were talking about was we had modified our geometry analysis code to use our calculate distance function. So we had called our own calculate distance function. We had fed in the coordinates of atom number 1 and the coordinates of atom number 2, and it had calculated the distance. And then we had saved that, the output of this function, we had saved as a variable called distance. And then that's what we were checking here when we were deciding what to print. So that's the next thing I want to make into a function. I want to make this checking the bond length into a function. So I'm going to create a new function. So I'm going to start with DEF. And the name of my function is going to be bond check. And if I think about how this function is going to work, I'm going to be basically feeding in one number, some, we'll call it bond length. I'm going to be feeding in some particular bond length, and then it's going to check and see if that meets my criteria for a bond or not. Okay? So my only input is going to be the bond length, and then don't forget your colon. And then if that bond length is greater than 0 and bond length is less than 1.5, if both of those things are true, I want to return true. And otherwise, else, if that isn't true, then I want to return false. And one thing I want to point out here is that you notice that when I typed true with a capital T and F with a capital F, it turned green. And we remember from our last lesson that that means that this is a recognized word in Python. So true and false are what are called the Boolean operators in Python. And that's why those are special words. Okay, so I'm going to hit Shift Enter. And it's going to seem like nothing has happened, but now my bond check function is active and I can use it. So I'm going to run some tests like I did last time. I'm going to say bond check 1.7. What should that be? If I do 1.7, should that be a true or a false by my definition of a bond? That should be a false, right? And it's false. Let me do bond check of, 1.2. That should be a true. There we go. Let me try bond check of -10. That should be a false, right? Because that is not greater than 0. So that gives me a false. Okay? Now, before we carry on, in this bond check function, my definition of a bond was being greater than 0 or less than 1.5. And I openly admitted to you that this definition of a bond was totally arbitrary, that I totally just made up that it had to be less than 1.5. So if this parameter is totally made up, then why don't we let the user specify it? Like if we're going to make up an arbitrary definition for a bond, why don't we let the user make up their own arbitrary definition? So let's do a little activity. I'm going to type your directions here. I want you to modify the bond check function to accept a minimum length and a maximum length as inputs. Okay? So instead of me just putting in 0 and 1.5, I want this function to accept a minimum length and a maximum length as inputs and use those numbers instead of 0 and 1.5. So I'm going to start by copying the function and just pasting it in this new box. And that's what you should do too. And then I want you to work on modifying it to accept a minimum length and a maximum length as inputs. Okay? So the two things you would need to do in order to modify the bond check function is the first thing you would need to do is inside your parentheses here, you should list two more parameters you're going to accept. And if you were tempted to name these parameters min and max, which is what I would have been tempted to do, you notice that both of those words turn green in the notebook. So those are actually reserved words that Python already has meanings for. So I would suggest not using those. So I'm going to use min length and max length. Okay. And that's the first thing I need to do. I need to add these to my list of parameters that my function accepts. And then down here in the body of my code, instead of having 0, I'm going to replace that with min length. And instead of having 1.5, I'm going to replace that with max length. Then don't forget to hit Shift Enter to rerun your cell and save these changes to your function. And now when I use bond check, I have more flexibility. I'm going to say my bond length is going to be 1.7, my minimum value is going to be 0.5, and my maximum value is going to be 1.5. So I'm expecting this to be false, which it is. But if I do 1.7, where I make the minimum 0.5 and the maximum 2, I would expect that to be true because I have changed the max length that I expect. Okay. Now, one more. Now, let's say a person did this. Let's say that they used the bond check function and they put in a number, but they forgot to put in the min length and the max length. Let's say they just forgot and they tried to do it anyway. Then right now, we're going to get an error. It's going to say that bond check is missing two required positional arguments, min length and max length. And you might think, oh, okay, that's probably good enough. That tells the user where they messed up and tells them that they need to go back and specify the min length and the max length. But other than just this error message, what's another thing that we could do to maybe make this better for our users? What's another thing that we could do to make it okay if they forget that min length and that max length? Does anybody have any other ideas? What's maybe something else we could do for our users to make it okay if they forget? Well, if we think back to when we used somebody else's function, like let's say we scrolled all the way up here and we looked at this NumPy genfromtxt, okay? In NumPy genfromtxt, for a lot of the parameters, it had a default value. Okay, so maybe that's something we could do to help our users. Maybe we could go back here to bond check. Here we go. Maybe we could go back here to bond check And maybe we could modify bond check where there are default values for min length and max length, where if the user forgot, it would use our default values. Okay? So this is actually pretty easy, even though I haven't told you how to do it. But based on what we learned and based on how NumPy genfromtxt was, see if you can think for maybe just 1 minute, see if you can think on how we could modify this function to give our users some default values. All you have to do is in your parameters list here, in the parentheses, if you want there to be a default value, you just put an equal sign and what you want their default value to be. So I want my default value for minimum length to be 0, and I want my default value for max length to be 1.5. Okay? That's all you got to do is just put, for those two parameters, just put what you want for your min length and your max length. Once you've done that, don't forget to rerun your cell. Okay? And then if I run these again, this one is going to come up false still because 1.5 is going to be my max. This one is going to come up true because I extended the max out to 2. But now this one, which previously gave us an error, is going to work, and it's going to tell us false because our default was our default maximum was 1.5, and this one is bigger than 1.5. Okay. Now, I have one more thing I want to do about this bond check function, okay? And that is, how is the user supposed to know any of this? Like, how is the user supposed to know how the bond check function works? How are they supposed to know what the minimum is? How are they supposed to know what the maximum is? How are they supposed to know what the defaults are? How are they supposed to know anything? And you might be like, well, maybe they could just ask for help. Maybe they could say, help, bond check. And there's just not anything here. Like, there's nothing here that tells them how this works. And the reason that there's not any help on bond check is because you didn't write any help for the user. Whenever you write a function, you should always write what's called function documentation to tell your users how this function even works. Okay, so I'm going to copy this and I'm going to paste it down here in a new box. Okay. And I'm going to write documentation for my function. And the way that you do this is after the very first colon, after you've defined it, before you start doing anything else, I want you to put 3 open quotes and then 3 close quotes. And in between here, you can write anything you want to tell your user what is going on. So I'm going to tell my user, this checks a bond distance to see if it meets the criteria for a bond based on a minimum and maximum length. I misspelled length. Okay. The default minimum is 0 angstroms. The default maximum is 1.5 angstroms. Okay. So now, don't forget to hit Shift-Enter and rerun your cell. And now, if I ask for help on bond check, Now it gives me real information. It tells me the usage. Bond check accepts a bond length, a minimum, and a maximum. And then instead of that being all that there is, it actually has these explanative sentences that I wrote telling my user how this function works. And really, if you're a good person, every time you write a function, you write documentation. And if we were really a good person, we would even scroll back up and find our calculate distance function, and we would write documentation for that too. I feel like this reference is getting a little dated, but in California, which is where I live, we're very obsessed with preventing forest fires. And Smokey the Bear says that only you can prevent forest fires. And the same thing is true about function documentation. Only you can write documentation for your functions. If you don't do it, nobody does. There's not some magical way that function documentation gets written. You, the programmer, must write function documentation if you want it to exist. Okay? Dr. Nash, was I emphatic enough about the importance of writing function documentation? I know that this is an issue you feel strongly about.
Yes, I think that was good.
That was compelling. You feel compelled.
Yes.
Okay. All right. So now we've written two functions, okay? And we've incorporated calculate distance into our code, but we haven't incorporated bond check into our code. So I'm going to scroll way back up. I'm going to scroll way back up here, and I'm going to find my code block, and I'm going to copy it. I'm going to scroll down, and I'm going to paste it in. And now I'm going to incorporate bond check into my geometry analysis code. So after I've measured the distance with calculate distance, now I'm going to say if bond check for distance is true, then I want to do this printing. And if it's not true, I want to do nothing. Okay? So I don't have to do an else alternative because my alternative is doing nothing. But now I can say if bond check of distance is true, then I want to do this printing. And if I hit Shift Enter, my code should work exactly like it did before because I haven't changed the functionality. I've just used my function instead of doing what I was doing before. Okay? So now I want to give you sort of a final exercise about function writing. So one of the things we did at the very beginning of our code is we opened the XYZ file and we took the slices and then we recast the symbols and the coordinates as different data types. Okay, so I want to see if we can move that into a function. So I'm going to make a new function, and the name of my function is going to be open underscore XYZ. And the only input that this function is going to need is a file name. Okay? And I want you to write all these middle pieces to open up this file, presume the file's name is file name. I want you to write all these middle pieces to open up the file, read it in, do the slices to separate off the coordinates and the symbols and recast them. And then I want your function to return the symbols and the coordinates. So this is going to be the last line of your function, is return symbols, comma, chords. That's going to return two things. So in this blank space that I'm asking you to fill in, I want you to open this file. Okay, so you're going to open this file and then do all the things you need to do to get the symbols and the chords ready to return. Okay, but your job is to fill in all of this middle stuff to open the file. And even though I didn't say it, you also are going to write documentation for this function, because remember, when do you write documentation for functions? Always. Okay? So I want you to take 5 minutes and fill in the middle of this function where you open a file that has this name and you do all the things you need to do to get the symbols and the coordinates ready to return.
Dr. McDonald, while we're waiting, I'm getting some questions about the bond check function and the sort of default values that we put in, and so sort of the whole process that we went through with the bond check function. Can you kind of talk us through that again?
Yeah, so I'm going to scroll back up. This is my sort of best bond check function. And there's a couple things that I did here. I originally started off with the only parameter it accepted, the only input being just the bond length. And then I modified it to accept a minimum and a maximum. So then, and I'm going to scroll a little bit, that would let you use the function in this kind of syntax, where you specified 3 numbers, the length, the minimum, and the maximum. But then we thought it was pretty common that our users might try this, that they might forget to put the minimum and the maximum. So then we modified it where there is a default value, and the way we specify a default value is that we just put an equal sign and we put what we want the default value to be. We specified default values for the minimum length and the maximum length. The other thing that we did here is we wrote some documentation so that if our users asked for help on bond check, they would get a message and not just get no information. I don't know what the question was. Do you think that was clarifying?
I think it was clarifying. It was on basically the default arguments and sort of how those work. So can you talk about maybe using, if someone were to call it with just one number versus 3 numbers, or what exactly different that happens?
So like here, if we called it with 3 numbers, then we could change the minimum and the maximum. So like here, I told it to do bond check of 1.7, and I specified the minimum at 0.5, and the maximum at 2. So in that particular case, when I checked 1.7, it came out to be true because I had specified the maximum was 2. But now, if I only use one number and I'm using my default values, the default maximum is 1.5. So if I don't specify the 3 numbers, then it's going to use the default. And in that case, 1.7 is going to come up false because the default value is 1.5.
Thank you, Dr. McDonald.
All right, I'm going to go ahead and go over this. I know some people have it, some people aren't quite there, but we can work with it. Okay, so the first thing I'm going to do is I'm going to write documentation because I'm a good person. So 3 double open quotes, 3 double close quotes. I can write anything I want in between them. This function parses an XYZ file and separates the symbols and the coordinates. All right. So then the first thing that I'm going to do is I am going to open the file named file name. So I'm going to say XYZ file equals numpy dot genfromtxt. My file name is my input, so I'm just going to put file name. So the F name is the file name. I know from my previous work that I'm going to have to skip 2 lines in the header, and I'm going to have to change the default data type from floats to Unicode because I have a mixture of symbols or strings and floats. Once I read all of this in as XYZ file, I am going to do my 2 slices. So my symbols are going to be XYZ file, every row, only column index 0. And my coordinates are going to be XYZ file, every row, column index 1 to the end. And then I'm going to recast my coordinates because I want them to be floats. So I'm going to say my coordinates as type float. And then at this point, I've accomplished my goals. I have used this input right here, and I've got my symbols and my coordinates ready to return. So that is going to be my open XYZ function. Don't forget to hit Shift Enter to execute that function. Okay, now I'm going to do something that's going to seem a little bit crazy, but I really want to sort of put this all together. So I'm going to go down to a new box, and I'm going to basically start my code over to show you the proper way to organize a code that has functions. Okay? So this is kind of like a fresh start for my code. So I'm going to write a comment. I'm even going to make a markdown cell. I'm going to say, this is my geometry analysis code, start to finish. And then since it's a markdown cell, it's just gonna neatly type that. Okay? So here I go. It's gonna be like I'm starting over at the beginning. So the way that you organize a code like this is that you begin with any of your standard library imports. So I'm going to start by importing NumPy and OS because those are my standard library imports. The next thing that you put when you're organizing your code like this is you put any functions that you have written. So I'm going to scroll way up here, and I'm going to find my calculate distance function, and I'm going to copy this, and I'm going to paste in that calculate distance function. And then I'm going to scroll up, and I'm going to try to find my very best version of my bond check function with my parameters and my defaults and my documentation. And I'm going to paste it in. All right. Then I'm going to find my open XYZ function, which should be pretty close at hand. And I'm going to copy it, and I'm going to paste it in. Okay. So again, I'm just reorganizing. You start with your standard library inputs. Then you do your then you put in your functions. And then you, and I'm going to delete this blank line because I think it looks funny. Okay. And then you actually start writing your code. So again, I've already written this code. I'm just reorganizing here. And part of the purpose of this rewrite is you're going to see how easy this is now that we have our functions. Okay. So what did I do in my code? I started by specifying my file location using OS path join. So I looked in the data folder, and then I clicked on water.xyz. Then the next thing I did was all that rigmarole with opening my file. But now I'm just going to use my function. So to get my symbols and my coordinates, I'm just going to call my open XYZ file and feed it in that file location that I just put together. Then I need to calculate my number of atoms. That's going to be the length of symbols. And the reason I needed to do that is because my number of atoms are now going to appear in my for loops. So I'm going to say for atom number 1, in range 0 to number of atoms, don't forget your colon, don't forget to indent. For atom number 2, in range 0 to number of atoms, don't forget your colon, don't forget to indent. And now, remember this earlier about doing the upper triangle. If the number 1 index is less than the number 2 index, then I want to calculate the distance by using my calculate distance function. And I'm going to pass in the coordinates of atom number 1 and the coordinates of atom number 2. Then, once I've calculated that distance, I'm going to check it, see if I want to print it. If bond check of distance is true, then I want to do my print statement. So I'm going to do my big F print statement, and I'm going to print the symbols for atom number 1, the word 2, the symbols for atom number 2, and then a colon, and then the distance. Okay? And notice I haven't hit Shift Enter a single time. This is all one big thing. But now, oh wait, I forgot one little thing. In the distance, I like to format that. I like to only print 3 decimal places. So I'm going to do :3F to only print 3 decimal places. And now, if I hit Shift Enter, it should print exactly the same thing it did before. And I can't quite all get it in one screen, but my entire code is now encapsulated in this one box. So let me go over this again. You start off with your standard library imports. Then I put in all the functions that I wrote. And if I was going to make this better, I would go back and write documentation for calculate distance. And then I sort of rewrote my code using my functions, and it ended up just being a very few lines. And this is my whole thing, all in one box. The reason that I wanted to get all of this code into one box, oh, I believe Dr. Falcon's just asked me this in the chat. Why did I want to get all of the code in one box? So functionally, it makes no difference. It would be totally fine to have everything in separate boxes. But the final thing that I want to talk about today is how to move this code out of the Jupyter Notebook and into a command line executable script. And in order to get it into that command line executable script, everything that I want to move into that command line executable script is now in this one box for me. Okay, so it was strictly an organizational thing because I'm planning ahead to the fact that I want to move this code out of the Jupyter Notebook and to the command line. And some people think that this is very, very important. They really don't like to be restricted to the Jupyter Notebook or they're worried that someday they're going to be on a computer that doesn't have Jupyter Notebook installed. And then what are they going to do? And some supercomputers are like that. Some of them don't have the Jupyter Notebook available, and you have to be able to run from the command line. And some people are kind of like, nah, I'm good with the notebook, McDonald. I don't feel the need to go to the command line. So it could be that this next part is kind of, a bonus that's not super needed. But some people are going to think it is the most important part. So that's why we are going to do this. Again, I'm just pausing here for another couple minutes to let everybody get this so that we can move to the command line. And Dr. Faltons, I don't know if going to the command line is something that is particularly useful to you personally or not, but that is why we are doing it, because we are getting ready to move to the command line.
Yeah, it's really interesting. I didn't realize that. I hadn't thought about the case where some supercomputers need the same code formatted a different way, for example. So this is great to learn about. I occasionally now find Python code, and I take it and I break it into chunks so it's easier for me to read and comment, and I put it into Jupyter Notebooks. And I probably don't fully understand. I like Jupyter Notebooks, and I don't use straight Python, so I don't fully understand when you would use Python that's not in a Jupyter Notebook versus Python in a Jupyter Notebook.
Yeah, I don't know that I understand that either. I'm a big Jupyter Notebook fan. I do almost all of my stuff in a Jupyter Notebook, but the most compelling example is if you're using remote computing resources and they don't offer the Jupyter Notebook. That's not an example.
Okay, thanks.
Yes, and also if you're, say, doing software development. So I mentioned that, like when we write functions, you make reusable pieces of code. So let's say this openxyz file was a function that we wanted to use a lot in a lot of different Jupyter notebooks. We could put that in a regular .py file. And if it's in the same directory as your Jupyter notebook, you can import the function from that .py file. Or if you wanted, you could make it into a Python package so that it wouldn't have to be in the same directory. So it's sort of like those are cases when you would definitely want just Python files.
So each function would be a separate Python file?
No, you can put multiple functions in a Python file. So when we do, this is maybe getting into too much detail, but let's say that you name your Python file like geometry analysis, which is maybe what Dr. McDonald is going to name it. If it's named geometry _ analysis.py and it's in the same directory as your Jupyter notebook, then you can do import geometry analysis, and then you can use any function that's in that .py file by saying geometry analysis function name. So it's just like, say, NumPy and matplotlib, and it can have several functions in that file.
I see. Very cool. Thank you.
All right. So my prescribed 5 minutes of waiting is up. So this is what I'm going to do. I'm going to highlight everything in my one box that I so carefully put together, and I'm going to copy it all. And if you don't have this box, if you were not with me up to here, if you click the link that Dr. Nash just pasted in the chat, it will take you to a website that will have all of the text that is in my box. So in some form or fashion, you should be able to copy all of the text that is in my box and then do the following. Okay. So I want you to come back over here to the tab where you do your navigation, okay, to your tab where you can see all your files. And I want you to click on MolSSI Workshop, and you should see the data folder beneath you, but we're not going to click on the data folder. And instead, we're going to come up here to the upper right corner where it says New, And instead of picking Python 3, which we've picked many times before, now we're going to go to new text file. And that's just going to open this blank white screen. And I am going to right click and I am going to paste in all of that information that I had in my box. Okay. So I've now pasted into my box all of the code that I had in that one box. Okay. So now I'm going to save this. So I'm going to go to File, Save, and it's going to save it as untitled.txt, which is not what I want the name to be. So now I'm going to come up here and I'm going to click on where it says untitled.txt, and I'm going to name this geometry underscore analysis dot py. And you can actually name it anything you want. I would encourage you not to use spaces. So if you sort of are tempted to use a space, use an underscore the way I did. And you could call it geometry analysis or geom analysis or whatever you wanted, but it needs to end in .py, and you do not want there to be a space in your file name. So once you've done that, hit OK. And now I'm going to go to File, Save again, which is probably redundant, but I just like to be super safe. Okay. So now we have all of our code saved as a Python file. .py is a Python file format. All right. Now, click back over here to the MolSSI Workshop folder, and you should now see your data folder. Remember, don't click on it, but you should be able to see it. And you should also see geometryanalysis.py. Now, come up here to the upper right corner again and go to New, and this time pick Terminal. And it is going to open a new terminal window, which may look familiar to you because this is how we did our data pull in the other day. Now, another way that we can run our code, is by typing Python space and then the name of our program. So mine was geometry underscore analysis.py. And if I hit enter, it is going to run my code. Oh dear, did I misspell something? What did I do? Geometry analysis.py.
Use ls and see if you see it.
Okay. Oh, I see my problem. You all probably had this problem too, and I should have done this. Okay, so let's kind of start over with the terminal. So when we're in the terminal, if we do ls, which is what Dr. Nash just wisely told me to do, ls stands for list. And if I do an ls, then I can see all of my folders. These are the same folders that I see right here, okay? My geometry analysis code is in my MolSSI Workshop folder. So the first thing I need to do is I need to change into my MolSSI Workshop folder. So I'm going to do cd, that stands for change directory, MolSSI underscore workshop. And then I'm going to hit enter. And then I'm going to do an ls again. And now I should see my geometry analysis program. So I see a raised hand. Who raised their hand? Oh, it was Dr.
It's just me. Oh, I was going to comment. Do you mind if I say a little bit more about the terminal?
Sure, go ahead.
Sure, yeah. So like Dr. McDonald says, what we have open right now is something called the terminal. And the terminal is basically just a text interface to your computer. So you can use your computer by typing things to the computer rather than by clicking on stuff. And back in the olden days of computers, though not a time that I can remember, computers did not have sort of the graphics or the graphical interfaces that we're used to using today. So it used to be that if you were using a computer, you would be typing commands to the computer, maybe through something that looked like this, like through a terminal, instead of by clicking on things. Right. Yeah, a computer mouse was actually, I think, invented in like the 80s. So before that kind of thing. So you can, if you do computer programming, you will interact with the terminal. So there are a lot of, say, computing environments where a terminal has to be used. And some of those would be supercomputers, but just other remote computing resources also. Dr. McDonald, do you have more to add on that?
No. Yeah, I just want to make sure everybody's kind of in the same place with me. If you do an LS and you see this line where it says CMS workshop data MolSSI workshop, if that's the line you see, then you need to do this command, cd _ MolSSI workshop. If you do an LS and you see something like this, data, your notebooks, and your geometry analysis.py, then you are ready to go. Okay, so now, this was supposed to be my big finish a minute ago, but now it's going to work. So now, if I type Python, and then I type geometry _ analysis.py, remember that was the name of my program, now it will run my program and it will print the same output I was seeing in the Jupyter notebook, but it will print it here in the terminal window. Okay? Okay, so I'm going to go over the steps just to make sure everybody remembers. So we opened the new text editor, we pasted in everything from that box, and we saved it as geometry analysis.py. Remember, the way we change the name is we just click on this and we type in what we want the name to be and we push OK. And then we started a new terminal by going new terminal. That opened this scary looking black box. And then I'm gonna clear my terminal and just to make it cleaner for everybody to see. Okay, so then if you opened a new terminal, then yours would look like this. You need to do an LS, and then you'll see your list of folders. Then you'll do cd MolSSI _ workshop, hit enter, do another LS, and now you'll see that geometry analysis file that we just saved. And if you type Python geometry analysis, I misspelled analysis.py, it will run your code and it will print the same output you were seeing in the Jupyter notebook. Okay. All right. Now there's one change that I want to make that I think is actually going to make our code like 50 times better. And it's going to be not very much of a change. Okay? So right now, the way that our code works is right now, the way that our code works is that the file that we're opening, and I'm going to click back over here to my text window. So here's my code in geometry analysis.py. Okay. Right now, the way that my code is working is that water.xyz is hard-coded in. And if I wanted to change what XYZ file I was analyzing, I would have to open my code in the text editor and somehow find this exact line and change it. What I would like to do is when I am typing in this Python command, I would like to tell it the XYZ file I would like to analyze right here on the terminal, and then not have to even go into my code to change anything. So those are the changes that I want to make, okay? And making these changes is it really isn't going to take that much, okay? So back here at the very top with my imports, I'm going to add a new library. And that library is called sys, C-Y-S, not C-Y-S, S-Y-S, okay? I'm going to import this new library called sys, S-Y-S, stands for system. And this is going to let me accept input from the system, okay? Now, down here, instead of having OS path join put my file location together, I want this information to come from the system. So I'm going to say system argv, and this means arguments. So this is going to be inputs from the system. And the name of my file is going to be argument number 1. And I'm going to explain why it's argument 1 in just a minute. Okay? So that's the only 2 changes I made. I added import sys at the top here. And then for my file location, instead of putting it together with OS path join, I said sys.argv1. And I'm going to explain to you why it's 1 in just a second. Okay? So now I'm going to go to File, and I'm going to save this. And now I'm going to come back to the terminal, and I'm going to type Python geometry analysis.py, and then I'm going to type the name of the file that I want to analyze. And I want to analyze data/water.xyz. That's the file that I want to analyze. Now, you can hit enter, and it should give you the same behavior. It should print the exact same thing it did before. But I want to explain a little more why it's sysargv1. So when we're on the terminal, everything that we type after Python goes in this list called argv. So everything after Python goes into the list. So this is argv0, which is almost always the name of your code. And then the next thing that you type after that is argv1. Okay? So that's argv0, the name of your program. So the next thing the user types is argv1. And that's why this was a 1. Okay? Now, here's the beauty of this. I can now do this analysis for a different XYZ file just by typing it right here. I don't have to change anything else in my Python script file again. So like if we look, one of the other ones that Dr. Nash has in our data folder for us is a benzene.xyz. So I can tell it do data slash benzene.xyz. And look, now it prints all the carbon hydrogen and all those carbon-carbon bond distances. And another one, let me see what other ones Dr. Nash has for us. Oops. Let me see what other ones Dr. Nash has for us in this data folder. Oh, this is the good one. Buckminster fullerene.xyz. So if I do Python geometry analysis.py, Buckminster fullerene.xyz, this is one of those big soccer ball of carbon structures. So I misspelled it, didn't I, Dr. Nash? What did I do?
I think you forgot the data.
Oh, I did. I forgot data. I'm going to show y'all another trick since I screwed this up. If you push the up arrow on your keyboard, it brings back the last line you typed. And now I can fix it. So it's in the data folder. And then it's Buckminster fullerene.xyz. And look, it's nothing but this big soccer ball of carbon. So all the bond links are carbon-carbon bond links. Okay? So again, the real power that we have gained by going to the command line is instead of having to find the line in our Jupyter notebook or find the line in our Python script to change the file name, now we have changed our code where all we have to do is type Python and then the name of our code, geometryanalysis.py, and then we can give it the file path to any XYZ file, and it will do this analysis for us. So I think that's pretty cool. I think that we could do this. Okay, so Dr. Faltons has asked an excellent question. Could we do something similar in the Jupyter notebook? Ask the user to input the file name. And you absolutely can. And Dr. Nash and I debated a lot about which one of these things was more useful for our last hurrah today, moving to the command line or showing you how to do user input in the notebook. So that's absolutely a thing that we can do. And I was trying to leave about 10 minutes for questions, but if there's no questions, I don't mind clicking back over and showing how to do this. But this was the big thing that I wanted to show you, is that you could move to the command line and you could just specify the name of the file here. Okay, so what I've done is I've come back to my Jupyter notebook and I've found the place where I say, this is my geometry analysis code start to finish. And I'm going to scroll down past my functions to where I normally do OS path join. Okay. So I'm going to delete OS path join. And instead, I'm going to say input. And then in parentheses, I'm going to type a message to my user of what I want them to input. And I'm going to say, enter the file path to the XYZ file to analyze. Okay? Now, if I hit Shift Enter, notice that this little box is going to come up and it's going to say, enter the file path to the XYZ file to analyze. And I'm going to type data slash benzene. I'm going to spell benzene right though, .xyz, and then hit enter. And then it's going to analyze that one and print it. Dr. Faltons, did that meet your expectations?
Yes, very cool. And I think I understand that it works. We don't have to do the path join because whoever's entering it will put in their own slashes in the right direction that works for their computer that they're on.
Exactly. Exactly. So again, the sort of two new things that we've learned here at the end is we can move our code to the command line and then do this sysarg thing and then run it from the terminal and type the file paths. Or if you're a Jupyter Notebook lover like me and Dr. Faltons, then instead of having OS path join put together the file location, we just put input and then in the parentheses what we want the user to input. And then when we hit Shift Enter, it will ask the user our question and we can tell it what we want it to do. I'm going to try to do Buckminster Fullerene again. Huzzah! And I wish that I had put a colon here instead of a period, because I think that looks better. Enter the file path to analyze, colon. Data / Buckminster Fullerene.xyz. There we go. Look at how lovely. Okay.